JC still special, he gets 2 L's. He told you were not the one. Oh no, dude. Wait, we can work. Do you have a pencil sharpener anywhere?
Yeah, it's back by the door.
Back by the door. Oh, God, I'm blind. That, no.
Okay. Alright. Good. Alright. So, what we're going to do today, we're going to do a couple examples of long division today to make sure everyone's comfortable with that. Once we're through the couple examples and everyone's getting somewhat correct answers, then we're going to move on to the last divisibility test. 9, 10, and 11. Those are the ones I want to finish with today. We did a couple of them yesterday. We did 2, 3, 4, 5, and 6. Okay, but we're going to do the last 3 today. 11 will be the one that we have to take the most time on because it's the one that's tricky. Alright, the rest of them are pretty straightforward. Alright, but let's start with long division. I want to do a couple examples of how long division works, how we actually work out a problem with this. So 1,455, and we're going to divide by the number 5. Because how do I know that the number 5 works? How do I know that 5 will work?
Well, if it
Well, I thought
ends
it was
in
5.
5 or 0.
Yeah, ends at 5 or 0. So I know this is going to work out nice and pretty. It won't have any remainder. It's going to work out and it'll have a 0 at the final number, so that's perfect. That's why I chose this. So I can create numbers on the fly because we know what we can divide by. So, what number goes in the house?
We know the
bigger
1,
number.
4, 5, 5,
Yeah,
5, 5.
the first one. Got into the house first, locks itself in. 1, 4, 5, 5. Put the house around it, put the 5, the divisor on the outside. That's the divisor, this is the dividend. It has to get into the house first. Dividend. Okay, now, when we do this, when we do long division, it's basically, I think of this, you are multiplying and subtracting. Multiplying, subtracting, multiplying and subtracting, which is really goofy because some people think, well, you're dividing the whole time. No, you're multiplying in your head and then you're going to subtract with a pencil. So what I try to do is I start here, 5, and I'll start with the first number. 5 cannot go into the number 1, 1's too small. So you always want to go bigger. So can 5 go into 14 without going over it?
No.
Yes.
Yes.
2 times.
5 times
2.
2. 5 times 2. 5 times 2 is
10.
10. So now, that's what you try to do. You try to multiply this number on the outside by some number that won't go over 14, right? So, or whatever number's sitting there. So 5 times 2 goes into that 10. I subtract. What's 4 minus 0? 4. 1 minus 1 is 0, so that's good. Bring down the next number. So now we're here. 45. And now we continue. Now we're doing the 45 now, this number. So 5 times what gets me closest to 45 without going over?
9.
9. Exactly 9, right? 5 times 9 is exactly 45. That's why it takes pure multiplication skills. You just have to have those flash cards ready where you know what 5 times 9 is. It's 45. I subtract, you get 0. 45 minus 45 is exactly 0. You bring down the last number here. How many times can 5 go into 5 without going over? Once. 5 times 1 is the number 5, and when you subtract, 5 minus 5 is 0. That's your final number. There's no more numbers to drop down. There is no remainder. That is exactly the answer. That is the quotient that you get on a calculator screen. They give you 291. That's the idea. Alright. Do we see how division works right now? You see the process we're going to have to do. You always multiply, subtract, multiply, subtract, multiply, subtract, and you just keep dropping numbers down so you can't go any further. Okay, let's try a bigger number now. I'm gonna let you guys create this number. So we're gonna go around the room, we're gonna make a really big number here. So first number please.
Wait, how big?
No, it's first number. Just give me a
5.
5, okay. Another number please. 9. Okay. Another number please.
8.
8. Okay. Another number?
4.
4. Another number?
9.
9. And last number?
7.
7. Okay. So now, I can already tell you right now, 5 will not go into it. Because it didn't end with a 5 or a 0. So we know 5 won't. Okay? What about the number 2? No, 2 definitely won't, because it didn't end in a 2, 4, 6, or 8, or a 0. So those numbers are out. But the options we still have. Obviously, if 2 doesn't go into it, 4 won't. 2 doesn't go into it, so 6 won't. So those are like the checks we learned yesterday. 3 might be our only possibility. 3 might go into this number. So here's how you check for a 3. You add up these numbers separately. And if that number is a multiple of 3, 3 will go into it. That's how it works. So we're going to add these together. So I'm going to add these one at a time. So this makes what, 14? And we'll just keep going here, and I'll just keep adding down until I get done at the end. 14 plus 8 is a 22. 22 plus 4 is what, 26. 26 plus 9 is 35. And then 7, and that's what, 42. Does 3 go into that? Yes, it does. How I know 3 goes into that? Would you agree that 3 goes into 30? 3 definitely goes into 30. 3 goes into 33 because I jumped by 3. 3 goes into 36, goes into 39, and it goes into 42 because I'm jumping by 3s. Because I start with the number that I know 3 goes into, it goes into 30. So it definitely goes into 42. So this number, this 598497 number that you guys just created, 3 definitely goes into it, nice and pretty. Because I added all those numbers up. So I'm going to divide this thing by 3. So we get 0 for remainder. That's how I know that this is going to work. We got lucky there. You guys picked some good numbers. So at least got something we can divide by. Alright, so what number goes in the house?
The 5984.
Exactly, the big number. 598497. Now we're going to divide this thing by a 3. Okay, I always start with the first number, and I see, can the 3 go into the first number? Yeah. 3 can go into the first number, right? 3 can go into that, what, 1 time? 3 times 1 is 3, and I didn't go over 5, so that's good. If I did 2, that would have been a 6, that would have been too big. So 3 times 1, that's 3, now I subtract. What's 5 minus 3? 2. Bring down the next number. That's how it works. You always bring down the next number after you subtract it straight down. Okay, so now we're at 29. How many times can 3 go into 29 without going over? Is that 3 times 9 is 27? So that's probably about it. 3 times 9 is 27. I subtract, I get 2, get a 0, so that's good. Bring down the next number. 8. How many times can 3 go into 28? 9 times again, so that's easy enough. That was another 27. I subtract, you get the number 1, and that's a 0, so that's a 1. Bring down the next number, 14. How many times can 3 go into 14 without going over it?
4.
4, what's 3 times 4? 12. You subtract, you get 2, bring down the next number. Jeez, just keeps going with these 29s, I guess. Alright, 3 can go to 29 exactly 9 times again, so that's 27. Guess what I get when I subtract? 2 and bring down the next number, which is a 7. How many times can 3 go to 27? Exactly 9, and you'll get a remainder of 0. Because I'll put a 27 down there and I'll subtract. This is your answer when you divide. That's the answer the calculator gave you. It takes skill. You need multiplication facts. If you do not know what 3 times 9 is, or 3 times 8, or 3 times 7, or 3 times 4, like you have to think too hard, I understand why you can't divide. Because you don't know what numbers to use. You don't know what number to multiply by. 3 times a number gives you closest to it. That's something you gotta realize. I gotta get close to 29, so it's 3 times 9 gives me the closest to it. That's why it takes math skills. It takes literally multiplication to do these types of problems. So, if you struggle with multiplying, if you struggle with it, I really truly recommend you work on flashcards until you get good at it. It's simple memorization. There's no other better way to do it other than memorizing with the flashcards. I'll tell you, okay? Alright, I'm going to give you a problem. I'm just going to give you an easy one. I want to see if you can long divide this by yourself. It's just going to be an easy one, not like this difficult. Something very simple. If you can get the correct answer, we're going to move on to the divisibility test today. That's what I want to see. Because I want to see, can you just get the basics done today? So here's our number. I want to try the number, let's go with 622, and we're going to divide by 2. Okay, I want to see you put it on paper, put the house. I want to see if we can get this number done. If everyone gets it right, we're moving on to the divisibility test for today. We can finish with those. Then I'll give you some time at the very end where you can work on homeworks, homework assignments. Yep. Nice. Good. Okay. You do here. Come back. Just wait until you guys are done and comfortable. Remember, multiply, put the number on the top, multiply and then write it down, then subtract straight down. Just make sure you're doing that. Wait till we're multiplying. Should work out nice and pretty. If yours didn't work out pretty, make sure you make it fixed. Okay. Hold up.
Oh, how'd you do that? How'd you do that?
Don't know. 0, 2, put a 1 here. Oh, okay. You did 2 times 1, right? So you did 6 and 6 rather than 2. What's 2 times 1? You should put that right now. You put a 0. That's what you want. That's what you want. So yeah, so looks like everyone's got the first couple steps right. The 622 goes in the house. The 2 goes on the outside. Everyone got the first couple numbers right. 2 goes into 6 3 times without going over. It goes in there exactly 3 times. So 2 times 3 is 6. You subtract, you get 0. Everyone brought down the next number. Now, the next number everyone got right. 2 times 1 gets me closest to this number, which is a 2. Now when you subtract, you get 0, correct? So now I gotta bring the last number down. How many times can 2 go into the number 2?
1.
Once, right? So alright, 2 times 1 is 2, subtract, you get 0. There's your answer, we got that. Okay. Good. So, easy fixes. Just knowing what you're multiplying by, writing down the number, subtracting straight down. Okay, let's talk about these divisibility tests. Pretty straightforward, pretty easy. I'll leave that there so you can look at that. Alright. Divisibility test. We talked about the numbers for 2 and 3 and 4. Divisibility test. Plural tests. Okay, number 2. How do we know if a number is divisible by 2? What do we talk about?
If it,
Or even.
yeah.
Even number at the end, right? That's the best way to put it. Right? That's the best way you can say it. The last number was an even, it's divisible by 2. What about 3?
All odds.
Not all odds.
If the
Yeah.
divisible.
Yeah, you add all the numbers together. So no matter what your number is, like the 622 there, you would add up 622, and if that number, when I add these digits up, right, 6 plus 2 plus 2, that's 8 plus 2, that's 10. Is 10 a multiple of the number 3? No. So you can't do that. What if I could change this? I could change it to this, and now it's definitely a multiple of 3 because when I add these numbers together, this makes 10 plus 2, that's 12, and 12 is a multiple of 3, right? 3 times 4 is 12. So that number here is definitely it's divisible by 3. You add up the individual digits. That's why it could be even numbers, because they could add up to be a multiple of 3 still. Okay? What about 4?
Last 2 digits are a multiple of 4.
Yeah, last 2 digits. That's probably the hardest one. The reason why I told you the last 2 digits, right? Well, if your number's really big, like this, how do you know if 4 goes into that? I know 2 did, but how do you know that 4 doesn't? So that's where you have to like start with numbers that you know 4 goes into. Well, obviously, 4 goes into 40. So if you keep adding 4, you see that I skipped over 42? It's 4's not in there. So it will not be divisible by 4. It goes 48, and you can keep going. And in another number that you know 4 goes into, it goes into 80. So now you can jump there, you can jump by 4s if you need to get bigger. So I always start with numbers I know 4 goes into, and then I start jumping by 4s to see if your last 2 digits go into it. Okay, 5. 0, 5 for last number. Yeah, so that's pretty straightforward. And the number 6. This is kind of a cheap rule, but for the number 6, what has to?
2 or 3.
2, 3 have to both work. So the rules for 2 and 3 both have to work. So you can add up all the numbers, it's a multiple of 3, and the last digits have to be an even of some sort. So both of these have to be yeses for your number, whatever it is, for a 6 to work out. In fact, the easiest way to do it is divide by 2 first, then just divide by 3 second, and that will give you the same as dividing by 6 in the first place. Okay? Alright, the new rules today. We don't have a rule for 7 or 8, there's no rule for that. But we do have a rule for 9. If your number is divisible by 9, you sum all the digits together again. Sum all the digits. So whatever your number is, let's say my number is this. Okay, 603,000. 603,000. If I add up all the digits together, so 6 plus 0 plus 3 plus 0 plus 0 plus 0, what would you get if you add up all those up? If you add up each of these digits. You get a 9. That's a multiple of 9, right? The number 9 is literally a multiple of 9. So it's a multiple of 9. Then yes, 9 will be dividing into that evenly. It could be any multiple of 9. So if I added these numbers up and they totaled 18, that would work, or 27, or 36. It's that little rule of 9. Sorry, that was my phone. It's the little rule of 9s where, you know, you hold your fingers. So like if you hold down the first finger, that's 9. 9 goes into 9. 18, so that's a 1 and an 8, so that's 18. I hold down the second number, that's 27. So it goes in there. 36, 3 and 6. 45. So if your numbers, if all these things add up to be one of these numbers, then 9 goes into it. Obviously the number I created there does. So it's kind of cheap, but it does work, and that's why it's nice to know your knowing the fingerings for 9s, so you can kind of get up to whatever number you need to. Usually, I very rarely ever seen a problem ever go over 27 for a number. Like when you add up all the digits, that would have to be an incredibly big number for you to get above 27 when you add them all up. All right, the number for 10. 10 is easy. What do you think the rule for 10 is?
Is there any 10?
Last digit is a 0. That's it. It's the only option. Last number has to be a 0. 10 goes into it. In fact, I can show you how to divide by 10 super fast. So somebody just make up a number without a 10 or with a 0 on the end.
1,000.
0.
7. Say that. I heard 307
994 0.
with a 0 on the end. All right. So that's 3,079,940. Do we agree that the 0 is on the end? Right? 10 goes into it. Here's how you divide by 10. This is the easiest way. If you know you have to divide this thing by 10, this is your answer. What did I do? Oh, sorry. I just made up my own number, didn't I? 997. I made up my own number. What did I do?
Got it.
Chop off a 0. If you divide by 10, you literally chop the 0 off the back. Easiest rule in the world. That's how you divide by 10 without doing long division. Okay, let's go to lunch. Come back, we'll talk about 11. 11 will take us the most time today. Okay, so, hey, let's continue on. We know the rule for 10, we know the rule for 9. Dividing by 10 is the easiest thing in the world just because you chop the 0 off. That's what I basically did there. Okay, 11. This is the tough rule. In fact, I'm going to use this board over here to do a rule of 11. If you know your number is divisible by 11. It's the last rule that we have that I know of, that I've learned. Most people know that when numbers are divisible by 11, they have repeating numbers, right? Like 22, it's divisible by 11, because it's repeating number twice. If you're divided by 11, you literally have the number that's repeated, so it's just the answer is 2. If it's the number 88, and you divide by 11, guess what the answer is? 8. That's just how it works, right? But it's different when you go to bigger numbers, like not 2-digit numbers, those are easy to look at. When you go to a 2-digit number, or sorry, 3-digit, I mean, and you divide by 11, this is different. This is how you know you have the right answer for a problem where it's bigger than just a 2-digit number. What the rule is, and I'm not going to write it down to words because it's a little too hard to write down, it would be too lengthy. Basically, you add every other number together. So that's every other number, right? You skip the one in the middle. If these two numbers add together, the ones on the outside, add together to make the number in the middle, then it's divisible by 11. So, does 2 and 2 add together to make the 4 in the middle? It's divisible by 11. It's guaranteed. It'll actually work out nice and pretty. In fact, 242, if I put it in the house, put the 11 on the outside, 11 goes into 24 2 times. 2 times 11 is 22. Subtract, you get 2, 2. 11 goes into 22 twice. That's your answer. So it did work out perfect. There was no remainder. So it worked out to be 22 exactly. Okay? Now, this can be any number. It's every other number added together. So let me make a bigger number now. Make a bigger number. 3, 1, 0, 4, let's see, 2, 0, 0, 0, 0. Big number, right? There we go. Is that 310,420,000? That's the number. Okay. This number should be divisible by 11. And that seems crazy because I just made it up and I put a bunch of numbers in there. Okay? Here's how it works. You add up every other number. Okay? So I'm going to start here in the front, add every other number. So I'm going to skip over certain numbers here. Let's add these numbers up that I put in black. Okay, that I've highlighted. So, what's 3 plus 0?
3.
Plus 2?
5.
Plus 0?
5.
Plus 0?
5.
5. So, when I add up all those arrows, it gave me 5, right? Let's add up the numbers I skipped over. 1, 4, 0, 0. Okay, what's 1 plus 4?
5.
Plus 0?
5.
Plus 0. The numbers worked out to be the same. It'll work out, it'll be divisible. It'll be divisible by 11. That's how it works. Every other number. That's actually how it works over here. That's literally what you're doing over here with the 2-digit number. Every other number. The first number, that number, because there was no other thirds, and you skip that number. Are they the same? Yeah, it's 8 and then 8. That's how it works. First and last number. So it does have the same rule for 2 digits. It's just really hard to put that into words. Now, it has to happen like that. Every other number has to add up. Now, it could be a very weird situation like this. Six, 1, 6 divided by 11. For some reason, this number is divisible by 11 as well. Even though the rule I just showed you doesn't work. Okay? Because we add up every other number, and we compare it to the one I skipped over. So what's 6 plus 6? 12, right? And the number I skipped? 1. Okay? Do you agree they're not the same number, right? For some reason, 11 still works. You want to know why 11 still works?
Because 11 can go into 12.
They differ by 11. The difference between 11 and 12 is literally the number 1. They differ, there's 11 gaps in between 1 and 12. So if you subtract these, and it's a number like 11 or 22 or something like that, it works. So the numbers can differ by 11. So just to show that it does work, I'll put it in the house. 11 goes into 61 5 times, that's 55. And when you subtract and you borrow, it's a 5, it's 11. 11 minus 6 is, or 11 minus 5 is 6. Bring down 6. 11 goes into 66 exactly 6 times. That'd be your answer for divide. It worked out nice and pretty. Because 11 times 6 is 66. So it does work out, there's no remainder. It just has to differ by 11. So that's weird. A lot of people don't see that. They always think they always have to be the same. Okay, any other questions with that? Okay, so those are the divisibility tests. These are the ones that, like, I know they don't give you answers. I know that. Except for the rule for 10. I mean, there's a shortcut there. But for these, they don't give you answers. But it is nice that you have a rule that you can start at the beginning of a problem and go, is this going to work? Or am I going to get a remainder, you know, before I start? Or will it be a decimal or fraction when we eventually get there? We'll try to review these rules every time we come back to a division section. Because there is sections where we come back to division and talk about it. Because we're going to need it for other purposes. So I'll try to remind you of, like, this is how we know if certain things are going to work. Okay, is there any questions with any of the stuff we've talked about today? Okay, you don't have any new homework today. I'm not giving you any new stuff. I'm going to give you time to work on page 19 if you need it. So that's due at some point today. Okay? You have the rest of the time to work. If you know you're done with page 19, you can turn in the basket. If you're still working on page, what was the page we had to do earlier this week? 10 and 13. Those are due. Put those in. Those are actually late. You need those. Alright, for the rest of the time is yours. Question?
If I know this and everything else, can I work on others?
Oh, yes, please. Yes. Always, yeah. If you need to study for a test or study, do some other homework, yes, please. That is always acceptable, because I realize I'm not the only teacher in this building. There's other homework other than mine.
Here's some work, have fun.
All done?
Yeah, very good. Yeah, I did. I'm in the blank sheet, I think.
Oh,
Just looking. Okay.
thanks. Perfect. Perfect. And then your grades will be updated over the weekend. I know some of you turned in some other work and stuff, those will be graded and put in, so don't like be stressed about it. They'll get in. I always grade on the weekends because volleyball takes up most of my time during the day.